All right, right now we're looking at quiz 1.04, most missed questions. This one is kind of taking that side splitter theorem and it is reversing it. We are looking at the opposite of the side splitter theorem, whereas normally you would be given two parallel lines. Remember, the side splitter theorem tells us that if you have a line that is parallel, the line inside a triangle that is parallel to a base of the triangle, then basically top to bottom equals top to bottom on each side. So in this case, it would be BD over DA would equal BE over EC. Now, in this case, they're not telling us that these are parallel lines, and we have to decide based on the situation. So basically, you want to see, is it true that top to bottom equals top to bottom? If so, then the lines would be parallel, and if not, then they would not. So let me erase these so we don't get confused. So for example, the first one, it says if AD is 2 and DB is 4, if CE is 3 and EB is 6, would those lines be parallel? So let's set up our proportions. 4 to 2, top to bottom equals top to bottom on the other side. 4 over 2, that simplifies to 2. And you could really, let's just cross multiply. We'll keep it simple because we could just simplify those fractions. But let's cross multiply because that's what we'll do each time, even when they don't simplify nicely. 6 times 2 gives us 12. 4 times 3 gives us 12 as well. So yes, those lines are parallel because the proportions are equal on each side. Let's try the next one. If AD is 2 and BD, instead of being 4, BD is now 3, and if CE is now 6 and BE or EB is now 9, let's try this one out. Top to bottom equals top to bottom. Cross multiply. 9 times 2 is 18. 3 times 6 is 18. Those check out. That means those two lines are parallel because the proportions are equal. What about this last one? Let's say, and let me erase these other ones here real quick. We're keeping AD as 2. They want to keep AD as 2 for some reason on these. So if AD is 2, DB is 5, CE is 4, EB is 7. So let's set up our proportions. 5 over 2 should equal 7 over 4. Cross multiply to see if that's true. 7 times 2 gives us 14. 5 times 4 gives us 20. That's a big no. So that means that these lines are not parallel because then that rule would not apply. The side splitter rule doesn't apply. So those lines cannot be parallel. Here's one with the angle bisector theorem. The figure shows triangle ABC. BD is the angle bisector of triangle ABC. So you see they have those angles marked congruent up at the top because it's cutting that angle in half, making the two smaller angles congruent. What is AD? So the side splitter theorem does tell us that similarly, it's like top to bottom equals top to bottom in this as well. The problem is we only know that the whole thing is 6. So how do we know what each little piece is? Well, the way we can tell is let's call AD X. And that means that DC would have to be 6 minus X. It would have to be whatever's left after we take away X from that whole length of 6. So DC will be 6 minus X. So we have 8 over X is equal to 10 over 6 minus X. Cross multiply. 10x is equal to 8 times 6 minus x. Distribute, distribute. 10x equals 48 minus 8x. We add that 8x to both sides. We get 18x equals 48. We divide both sides by 18. And they want this as a fraction, it says. So you can do a couple things here. Most of your calculators will actually make this a simplified fraction for you. If not, you can just start by using prime factorization. Whatever is going to work for you is totally fine with me. In decimal form, you're going to get 2.666666, but that's not what they're asking for. So you are going to need to, again, make sure you get this in fraction form. As a mixed number, it's 2 2/3. If you want to convert that, you can, and you would get 8/3. However you decide to simplify, you might notice that 6 comes out of both of these as well, and you can simplify that way. However you like to simplify your fractions, and that would be your answer. AD is 8/3.